Hi, welcome back to Science 1206, the Chemical Reactions Unit. I'm Miss Ledwell, and in this video, we'll continue our review of some chemistry terms. So let's get started. First, let's review the period number. Remember that the periodic table is organized into horizontal rows referred to as periods. There are 7 periods, each beginning on the left side and progressing across the periodic table. For example, period 1 contains the elements hydrogen and helium. Period 2 contains lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Period 3 starts with sodium. Period 4 starts with potassium. Period 5 starts with rubidium. Period 6 starts with cesium, and period 7 starts with francium. The period number tells the number of energy levels an atom has. For example, silicon is in the 3rd row of the periodic table. Therefore, it is in period 3, and it has 3 energy levels. The vertical columns in the periodic table, numbered from 1 to 18, are referred to as groups. The group number is written above the vertical columns on the periodic table. For example, here we have group 1, which contains hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Here we have group 2, starting with the beryllium. These are the alkaline earth metals. Highlighted in red here in the middle of the periodic table, we have the transition metals. They cover groups 3 to 12. Group 13 comes next, starting with boron, followed by group 14. We can see that one starts with carbon. Group 15, starting with nitrogen. Group 16, starting with oxygen. Group 17, these are the halogens. The common ones are fluorine, chlorine, bromine, and iodine. And then we have group 18, which are the noble gases, starting with helium. The group number of an atom in the main groups, groups 1, 2, and 13 to 18, indicates the atom's valency, which is the number of electrons located in the outer energy level of an atom. For example, atoms in group 1, like hydrogen, have 1 valence electron. For the groups represented by a double-digit number, we look at the second digit. For example, atoms in group 13, like boron and aluminum, have 3 valence electrons. We can see in the Bohr-Rutherford diagram here, boron has 3 electrons in its outermost energy level or shell, so it has 3 valence electrons. Atoms with space in their valence shells can gain or lose electrons. For example, alkali metals like sodium have 1 electron in their valence shell, while halogens, such as chlorine, have 7 valence electrons. This makes atoms in these families highly reactive as they look to gain or lose electrons to become stable. The noble gases are usually unreactive, meaning they do not typically form new substances with other atoms. This is because their atoms have filled valence shells, which makes them stable. So, for example, helium has 2 electrons in its outermost shell, but that's all that can fit in that shell. It has no empty space in its valence shell. Next, let's review how to create Bohr-Rutherford diagrams, also called energy level diagrams. Let's create a Bohr-Rutherford diagram for phosphorus. The first thing we'll do is start by creating the central nucleus. We're going to draw a circle for that. Next, we'll calculate the number of neutrons in the atom by subtracting the atomic number from the mass number. So remember, to get the mass number, we take the atomic mass, 30.973761998, and round it to the nearest whole number, which would be 31. And then we subtract the atomic number, which is the whole number in the corner. So we have 31 minus 15 gives us 16 neutrons in phosphorus. Now we're going to record the element symbol, the number of protons, and number of neutrons in the nucleus. So we have the element symbol P for phosphorus. We have 15 protons. I get that information by looking at the atomic number in the corner, which is the whole number, and 16 neutrons, which I just calculated. Starting with the electron shell nearest to the nucleus, fill in the shell up to the maximum number of electrons. Remember, the order the shells fill is 2, 8, 8, 18. So I'm going to have a total of 15 electrons. I know this because the number of electrons is the same as the number of protons in a neutral atom. I'm going to put 2 electrons in the first shell, 8 in the next one, that gives me 10, and I need 5 more will go in the valence shell. And we've created a Bohr-Rutherford diagram for phosphorus. Take note of the number of electrons in the outermost energy shell and compare it to the group number to be sure you're right. We have 5 electrons in the outermost energy level. So for phosphorus, we look at the periodic table and we see that phosphorus is in group 15. And we remember that for the double-digit groups, we look at the last digit. That should be the same as the number of valence electrons. The last digit is 5, and there are 5 valence electrons in phosphorus. Now it's time to do some practice. Complete the learning activities you'll find in Brightspace.